I was carrying the scripts and all the graphs and all the tech to record that, and this is actually our school lunch. Hashtag love student life, and that was cringy. And yeah, my backpack, the load has literally gotten lighter on my back after making that video. And now it's time for health class. Hello, and welcome to the Average History Notes podcast. As you can see, I'm missing my two partners in crime, Andy and Tyler. They're unfortunately unable to be here. Today we're going to take a little different approach. Normally we talk about U.S. history, and today we're actually going to be talking about a little mix between world history, world governments, and science. If you haven't seen already by the caption of this video, I'm going to be talking and giving you guys a pretty big overview of global warming, all the science behind it, what governments have been trying to do. I would like to start off by saying this is just facts. I'm not going to say any opinions in here. You're free to believe whatever you believe. I'm not going to try and convince you otherwise, but all these things are scientific facts. I'm going to start off by establishing my credibility by naming my sources. Union of Concerned Scientists, PreventClimateChange.com, NASA's Meteorology and Global Climate Change Branch, and then I also wanted to include something for the skeptics out there because I didn't want to look at just one-sided sources, even though those are all, I mean, NASA's pretty credible. All of them are pretty credible. I even use skepticalscience.com, so hopefully this presentation should be credible enough for you. So, okay, over the past million years, as you can see, there's been natural fluctuations in the Earth's climate. So this shows temperature, basically. All the way from 10 degrees Fahrenheit to -20, that's an average already. So, as you can see, around every, I don't know, a few thousand years, it goes up, down, up, down, up, down, up, down. This is probably the past 100,000 years, and as you can see, there is a very big increased spike. But other than that, pattern looks pretty normal, right? So, as you can see, this is also the last 400,000 years for a closer look. As you can realize, there are two colors. That is because as a temperature, and blue as the amount of CO2 in the atmosphere that scientists think happened at this time. Now, this has gone up and down. This is, of course, in years before present. So this is the present, this is the past. As you can see, we have gone up, and we are recently in a large spike. So, moving on. That large spike, what does that look like? And not just in the past few thousand years, but in basically just years in general. This is the past roughly around 100 years. As you can see, compared, there's this normal spike. We are at the top of the spike. There's little rifts, and this is what they look like. Again, if you can't see, this is the temperature compared with CO2. There's a recent spike among our spike, which is a little scary. Okay, and it seems a little bit off, but there's a natural trajectory to these spikes, and this is the blue, right? This is the natural trajectory of what our intense spike should look like at the end of our 10,000 years. And the red is where we're going with global warming. As you can see, there is a normal, even the spikes do follow a constant rate, and we are increasing very much so. So, yes, that's why scientists are mainly concerned. That's why people are concerned, is because even though there's the top of ours, we're pretty big. To put that in another perspective, this is what it looks like. As you can see, back from 300 years to 1900s, you're going very big. The red shows it's an abnormality in our abnormality cycle. So, okay, there's a natural, as I said, there's a natural up and down cycle. Now with this, you can see the CO2 is rising a little bit faster. So, yeah. Next thing, which most people actually, want to know, what's causing this spike? What's doing this? In a recent study in 2017, scientists tracked the amount of CO2 that was released into the atmosphere, at least what they could, and measured that back to certain things. There are three main causes: solar, the sun's radiation going down, volcanic energy, and human caused. Alrighty, a little background for that, if I can find my graphs, is, okay, solar activity and temperature. So basically what happens is the sun rays come down into the earth, and they are trapped in this thing that's called the heat blanket. So normally these solar rays come down and bounce back up and they go off into space. But right now the CO2 is kind of blocking them and keeping them. So all this energy is coming down, and the energy, like I mentioned before, is basically heat. So it's creating all this heat in the stuff, which is building and building and building, and it's not really going out. So I'm looking at this graph, which starts at the 1800s, finishes with present day. This is a solar iridescence, basically how much has come in. The universe, as you can see, there's normally a spike. They're pretty much in sync. And then recently the temperature has gone all the way up, which is, again, concerning. People are going, so this means that the CO2 levels that are rising and the temperature are rising is not because of solar activity. So, now, yeah, volcanic activity. This is kind of separate, but it's a fun fact anyways. Technically, if a volcano goes off and erupts, just a medium-sized, nothing like a little poof of smoke or a little weird kind of earthquakey stuff, nothing like Yellowstone. But in the middle, normally when a volcano erupts, it releases enough CO2 in the atmosphere as much CO2 as if every car on this earth right now was left running constantly for 100 years. All that CO2 emitted is the equivalent of what is released out of a volcano with one eruption, which is pretty weird. So looking back on that at first, that really threw me off, because I was like, what if recent volcanic eruptions? As you know, there hasn't actually been an increase in volcanic eruptions technically in the past. We've actually had a buildup of a large one. There's nothing out of the ordinary in that. So it can't be volcanic, can't be solar, which means that what is driving this? Humans. Yay, love that. Yeah, as you can see, human activities burning fossil fuels far exceeds solar radiation in the past 260 years. That active radiation forcing is not only double, triple, but almost 20 times that of any solar. Volcanic is actually negative in the graph, if you want to take a look at that closer. Now, I will say, every time I bring this up with my dad, he brings that there's no actual evidence from what life was like 500 years ago, 1,000 years ago, millions of years ago. No one was actually there with a thermometer being like, oh, look at that, oh, air temperature. No, that actually didn't happen. These facts that I'm presenting today are based off of rates that we calculated today. Thousands of factors were varied in, and then they were calculated based on time off of geological records. Everything, human population, things that were going in governmental powers, everything we know from geological records to atmospheric records to meteorites to everything, that all has been calculated in. And so going back, when I showed you these first maps millions of years ago, no, it was not. People weren't actually, in the Stone Ages recording the temperature, but based on evidence they found, that's what they think it is. So just like to throw that out there. Okay, so clearly, hopefully I've proved that. Okay, so I just threw a lot of information at you guys. So to review, I have another handy dandy chart, just because I absolutely love data, especially when it's graphed. This is the natural fluctuation of the years, different things. As you can see, there are natural ups and downs, and in those ups and downs, smaller ups and downs. But the amount of CO2 in our atmosphere has increased and is above almost double what we've ever been before. For centuries, atmospheric carbon dioxide has never been above this line. This is what it was in the 1950s, the line based off the average. You can see that is what it is today now. So it's a concern. Basically, though, why does this matter? That's kind of the big question. We have things like, for rising temperature, we have air conditioning, we have scientific breakthroughs, all these things for carbon dioxide. You're like, why does that even matter? I'm still breathing in oxygen, we can still filter, our lungs are working, that's okay. So I'm going to explain now why this is a problem. It's a problem because all this CO2 is being brought into the atmosphere, and it's not staying in the atmosphere. It's going into things like our oceans and affecting our different wildlife. So it's going into the ocean because the ocean is the world's biggest carbon sink. A carbon sink is basically a fancy word for things that absorb carbon dioxide. And so what's happening is because the ocean covers 75% of the Earth's surface, almost all this carbon dioxide is being stored in the oxygen, which as this increases, this means that the temperatures increase, acidity increases, basically not good. So if you can look, there's things pH, the average acidity for the water. This is a past around 50 years. This is the amount of CO2 that's been in the atmosphere. As you can see, a steady rise. We already established that. That is the amount in the water, and it is steadily going up. Now the pH is going down as this happens, which means that as this does happen, the oceans are getting more acidic. That's a problem because it kills wildlife, snails, clams, sea stars, coral, reef ecosystems, deeper level species. All of these things can only withstand a certain amount of acidity, and when that acidity raises, things happen. Snails, shells, they start to decrease, they break a lot easier. Starfish are becoming extinct, especially deeper level species are being affected because all that carbon dioxide is being stored in the very bottom of the ocean and slowly coming up as time goes. And so that's naturally where we see the most change. Now, because we don't know very much about the ocean, we don't know how this is affecting animals, but if you're a fisherman or anything like that, I wouldn't be too surprised if you started seeing changes in the next few years just with the amount of carbon dioxide that's rising. Alrighty, violent storms, Hurricane Katrina, all these different things, those were not happening a few hundred years ago. Again, looking at geological evidence and records, yeah, none of these have been happening. The ice caps with the temperature rising, they're melting, which is dramatically raising sea levels. Woohoo! When things get hot, they expand, and so not only is the iceberg breaking apart and melting, but the water is slightly expanding too. So even 1 degree difference changes thousands of tons of water trapped in icebergs. It makes the water come up and it rises, which is, again, very depleting for scientific structures and the things that we have developed along our coastline. So that is why it is important. Also, if you haven't realized, 1988 we recorded the hottest summer yet on record. This shows the seasonal cycle since 1880. As you can see, in the summer there's a very hot dip in December, and coming out of that in January there's a very low dip. 1880, that was the first recorded temperature. And this is what it is today. We, on our natural cycle, have slowly been increasing over and over time. If you can't tell by the pretty rainbow, that's the years coming up. That was what was last measured in July 2017. This is the most recent graph I could find. So, temperatures have been getting hotter and hotter. That's not you, that's actually happening, that's science. So, moving on, now that we've established there's a problem, why it's a problem, and what's happening, I'm going to talk about more of the history part. What are governments today doing, and what's the actual history of human act in this phenomenon. Okay, so first thing, going all the way back to 1895, a Swedish chemist, I'm going to butcher this name, but I think it's Svante Arrhenius, thought that CO2 might actually be cooling the Earth, which was a really big, not quite breakthrough in the scientific community, but it was a very kind of shocking idea. As more people looked through and through, they were like, oh, okay, this is happening. Later, Arrhenius actually canceled him and challenged him, saying, no, I don't think that it's going to happen. I think the reverse is going to happen. The more CO2 that's in the atmosphere, it's actually going to make the temperatures rise. Alrighty, flash forward almost 100 years. It's 1958. Keeley Curve revealed in the Institution of Oceanography in Hawaii's observatory that there is a thing called the Keeley Curve. That is basically the curve going up in temperature past the normal fluctuations. Remember that graph that was up and down for the past few millions of years? Yeah, that's the curve going off that curve. That's us breaking this natural cycle that's been going on. Alrighty, number 3, if I can find it. 1970 scare. If you're alive, you probably remember it. People thought that pollutants would actually cause global cooling. They thought that the amount of pollutants that were being reduced into the atmosphere were going to be causing it. The chemicals leaking off of that were just going to cause more and more problems, which it does, but it's actually just doesn't cool the Earth. Alrighty, the fourth is kind of, fourth event I'm going to talk about is kind of linked. 1988, that's when the hottest summer is ever recorded on record for the past around 400 years. And that's when people realized that the opposite wasn't happening. The Earth wasn't cooling down, but it was actually getting warmer. And when this happened, the IPCC, the International Governmental Panel on Climate Change, in other words, a global scientific leadership, was created. Yay! That is still a very big part of our society today. After that, we decided to be a little more proactive in the governments. 1992, that's when the Earth Summit was held. That's basically what it sounds like. Some of the world's largest governments got together and said, alrighty, we are going to, try and make a plan for climate change. Alrighty, 1992, I'm not gonna say this right, but Kyoto Protocol was made. It was an international treaty to limit the government's amount of CO2 emissions are released into the air. In some places like Europe, they even ended up putting a tax on cow farts because that releases huge amounts of CO2. As ridiculous as it sounds, governments have been trying to get these. Now, the US produces 1/4 of the world's greenhouse emissions, which if you don't know, greenhouse emissions is directly lied to CO2 levels. So basically, it was a big deal that we are part in this and that we limit our CO2. But under Bush, we resigned from this. He thought it would hurt our economy, and he thought our economy was more of a concern than the global warming. So he pulled us out, and we have never been enacted in that protocol ever since. And we have not had very many limits on our CO2 emissions. Alrighty, after that, which was so friendly, the UK in 2003 made the Friends of the Earth law, and they've been trying to get a law passed which limits the CO2 released by each country signed in the UK. Again, that would mean we would have to limit it. Now, more recently in 2017, Trump kind of pulled us out of this, and he also cut our budget for spending on global warming. As you can see, this is our graph. We've normally been spending around $2 million of our budget out of the $20 billion we spend every year on climate resiliency, basically meaning that the effects of global warming have been causing all these problems throughout America. We have spent $20 billion trying to clean those up and get ourselves out of that mess, while we recently dropped to having a budget of, you can't read, $0 spending on supporting the IPCC and various other things that are going and helping against climate change. So that is basically what's happening. Yes, those are the facts, so there's the exact dates. Again, I explained how scientists think they know what was in the past. You can believe whatever you want, but this is the Average History Nerds podcast, and we're just gonna try and bring you the facts. You can believe what you want, you can believe what the scientists say, just saying. This is a map of all real recorded temperatures throughout the world. This is a map. You know how I said that we don't actually know what happened in caveman times because they weren't recording? This is when humans started recording. I don't know about 2,000 years ago, but all I know is that we have a really sharp increase that we've actually recorded. Again, this was provided by NASA. Just gonna say. All of these things are extremely credible sources. I'm not bringing this to you to scare this. I'm bringing this because I hope humans can turn it around and make a change. What you do after this, that's up to you. This is Julia Navidi. This is the history of global climate change podcast. Until then, I'm Julia Navidi, and this was the podcast. Average History Nerds, please subscribe, and we will be bringing you more episodes every week. So this has been the history of climate change.